Hello and welcome to Mr. Panza's video lesson on how to complete function tables. I'm sure function tables are things that you have seen in the past, but one thing you have to recognize is that this is truly algebraic thinking, trying to solve for equations that you're not sure of pieces of the number sentence, or at times you're trying to figure out the actual answer or rule. Functions and tables. What is a function? A function is a rule, sometimes using variables that changes a number or the input, using multiplication, division, addition, and or subtraction, creating a new number or the output. And the way you can determine if it's addition or multiplication is if the number typically is going up, and if it's subtraction or division, the number is normally going down. In the incomplete equation blank plus 5 equals blank, we know that the square box is the actual input. The line at the end of the equation would be your answer or the output. And finally, plus 5 is the rule. Typically in algebra, we do not have this rule. We have to understand what the rule is by applying some strategies and then apply the rule. First of all, let's take a look at this incomplete equation. Blank plus 5 equals question mark. But let's put 2 into the actual square box. Well, once you apply the rule, then you'll know that the answer is going to be 7. The output then is 7. Solving for the rule, however, is really where the algebra and the algebraic thinking comes into play. If you're given the input and the output, you must determine how the number changed using either addition, subtraction, multiplication, or division. So if it's 6 blank equals 9 or 7 blank equals 10, you know that it did something. They changed something. How? The rule must be plus 3 because 6 plus 3 equals 9 and 7 plus 3 equals 10. If you're thinking about it in the algebra sense, you know that from going 6 to 9, they increase the number. So the only way you can increase a number in mathematics in this case would be addition or multiplication. 7 increased to 10. So again, it must have been addition or multiplication. And in this case, there's no skip counting method from 6 to 9 unless you had previously known that you were skip counting by 3. And 7 certainly can't skip count because when you skip count by 7, you're going to go 7, 14, 21, 28. So that doesn't get to 10, which means it must be addition. And when you go 6 to 9, you're adding 3, and 7 to 10, you're also adding 3. Let's first take a look at a function table where you are given the rule. For example, they tell you that the rule is going to be plus 5. So if the input is 5 and you add 5 more, then your output is going to be 10. Let's continue this chart. 7. That's going to be there. Your output then is going to be 12 because your rule is plus 5. 10. Apply your rule plus 5, get 15. 13. Apply your rule plus 5, get 18. 15. Apply your rule plus 5, get 20. Notice that the rule only applies to what you are putting out. This, on the inner part, is not increasing by 5. That is the part of the equation that doesn't change. The 17, now apply the rule and get 22 because you added 5. However, sometimes you look at function tables and you're missing the actual rule. We don't know the rule, but we're given enough information to solve for this equation. 6 goes up to 18. 4 goes up to 12. Using the pieces of information that we have, we can find the rule first and then solve the rest of the function table. Well, I know because this number is increasing from 6 to 18, we're either adding or multiplying. So I know in order to add, I would have added 12. However, that cannot be the rule because 4 plus 12 is not going to get me 12. So I must have multiplied. Now you have to solve, what did I multiply by? Well, there's an algebraic way you can find how you were able to multiply or what number you multiplied by, and that's doing the opposite operation. You would take 18 divided by 6, and you would know that, oh, 6 was multiplied by 3. That's the rule. 6 times 3 is 18. Does it work for 4? 4, 8, 12. 4 times 3 is 12. That works, which means if I apply multiply by 3 to this number, I'm going to get 15. If I apply multiply by 3 to this number, I'll get 21. Now the function switches. So they multiplied some number by 3 to get 9. Well, I know that that's 3, but if you're not sure how to get that, then you would take 9, you would have divided it by 3, and you would have found out what the input was. Let's try it here. We again are missing the input part. We know it is some number times 3. If you don't know that off the top of your head the answer's 10, then take what your output is and do the opposite operation. In this case, divide by 3, and that will get you your input equation. The rule, multiply by 3, or if you're not given the input, divide by 3, and you can solve for the equation. How about this? We're missing the rule again. Now, instead of increasing, we are decreasing. So from 18 to 12, what did they do? They either divided or subtracted. And in this case, they had to subtract because there's no division that's going to get you from 18 to 12 and 10 to 4. It just doesn't work. But subtraction sure does. 18 minus 6 would get me 12. 10 minus 6 would get me 4. 20 minus 6 would get me 14. 9 minus 6 will get me 3. And now I'm left with the blank opposite side. Well, if I subtracted to get the output, then I need to add to get the input. Remember, I was subtracting by 6, so I do the opposite. I add by 6. That gets me 16. Again, I have the output. How do I find the input? The opposite. I add 6. So the rule was subtract 6. Place the input, subtract 6, and get your output. That's how you find a function table. Be sure to check back for other videos on how you complete function tables using algebraic thinking.